Okay, I'm going to run through these really quickly. In case you need to fill these in, you can get your notes filled in with these. All right, bedrock. Essentially parent rock to soil. Pretty much, this isn't always the case, but pretty much everything that's above the bedrock has risen from that bedrock at some point. It's the bedrock is the the precursor. It's what everything else is formed from. Soil is essentially weathered bedrock. Kind of saying the same thing. Obviously, there are some other things added in there to create fully mature soil, but essentially it's weathered bedrock at its most basic. Residual soil. So that's soil that where it is, it's formed from the bedrock directly below it. So it hasn't been brought in, or it hasn't come from someplace else. It's directly from the bedrock that it is above. And this diagram does a pretty good job of showing kind of the basic steps in soil production or soil formation, I should say. From just bare plain rock to where that starts to weather and break down, and then you have some soil formation, and you have a much more mature soil profile at the end. Okay. Transported soil. So this is soil that has its origin somewhere else other than where it ends up. So it's been transported somehow. So here in the upper left, we have a river that has sediment in it. You can tell by the coloration, that it's sediment. It looks like it came from the rocks above it. Here in the upper right, we have a river delta as it enters some oceanic body of water, and all the sediment, the cloudy looking stuff in the water, sediment that the river is bringing to the ocean. Then alluvial fan. So all this sediment's been washed down, the mountain. And then here we have glacial till. So as the glaciers are progressing, they're moving all sorts of sediment. And then when that glacier stops progressing and starts retreating, it leaves all that material. So here in Indiana, for example, you can find rocks that really have no business being here because we don't have those types of rocks here naturally, but it's been brought down from Canada because of the glaciers. So kind of a, I guess, real world example of that. Soils are different. The main differences in soils is climate. Climate and moisture. It can make soils either more fertile or less fertile. A lot of the water, too much water and too much moisture can actually pull the nutrients out, like in tropical rainforests, through a process called leaching. So all the nutrients are basically just washed out of it, and it's really not very fertile. Whereas the desert, not a lot of soil, but a lot of nutrients because there isn't a lot of water to leach all the nutrients out of it and pull them out. So permafrost. So in the Arctic, not a good place to try to grow things. Probably the biggest reason, the ground's frozen all the time. Trying to grow plants in ice is not a good plan. So soil profile. So this is a full soil profile from the surface all the way down to bedrock. It's kind of the whole thing. So the soil profile is the total thing that's made up of different horizons. So the soil profile is a side view of, like I said, from the surface down to bedrock, and it's made up of horizon A, which is known as topsoil. So this is absolutely necessary to grow pretty much anything you want to grow. is where the nutrients are. It's loose, so plant roots can get through it and grow. Without topsoil, you're gonna have a tough time growing anything, at least pretty much anything worthwhile. Excuse me. Horizon B, the next layer down, is subsoil. So topsoil is the top, and then subsoil is directly under that, which kind of makes sense. It's primarily clay. Here in Indiana, we have a lighter colored clay, typically kind of a grayish color. Whereas further south, southeast U.S., you get into that red clay, which is a result of iron, iron oxide, so rust. And then Horizon C is where the bedrock is starting to weather, so it's starting to break apart. So Horizon A is topsoil, Horizon B is subsoil, Horizon C is weathered bedrock, and then below that is just solid bedrock. So it's kind of a full soil profile. Soil conservation. So because it takes so long for soil to form on its own, soil conservation is important. So reducing erosion either by wind or water or both, and trying to keep the soil as healthy as possible by keeping nutrients in it. It's a big deal. Not just for farmers that make their living with the soil, but also us as consumers, as people that eat things that farmers grow and produce. It's an important thing that the soil is taken care of and looked after properly. So one technique is no-till farming. So basically the farmers try to disturb or disrupt the surface of the soil as little as possible. Every time the soil is tilled over and turned over, it makes it more susceptible to erosion. It's much easier for that soil, once it's been broken up and loose, to blow away or wash away, all that. And a lot of that is because of whatever the crop is, the roots that are in that the soil, kind of interlock all that soil in place. As soon as you start breaking all that up, then like I said, it makes it more susceptible to erosion by whatever agent. The next one, tall trees, windbreak. So in areas like the Great Plains where it is very flat, wind can come across those plains and those areas, and there's really nothing to slow it down. So wind erosion can happen pretty easily. Also, with a lot of wind, it's going to dry things out. So some farmers will plant windbreaks, so rows of trees basically just to disrupt the flow of wind, just something to get in the way so the wind has to go over it, and just to kind of slow it down a little bit. The next one, contour strip farming, strip cropping. Similar to windbreak, but just using two different crops with different heights. So it just again disrupts the wind and changes the wind pattern a little bit, and it just kind of disrupts that to slow the wind down a little bit. We also have contour farming. So with this, planting with the slope. So if there's a hill, instead of just plowing over the hill to where water would just run down those channels and actually pick up speed and erode a lot of material. With that, if there's a hill, then you plow around the hill. So any water that goes down, it has to go over those ridges as it goes down the hill, so it slows it down and reduces erosion that way. And the last one are terraces. We don't have those much in the U.S., certainly not in the Midwest. These are for places, they have some of this in Southeast Asia, or Asia, I should say. Some in South America, in the Andes, the Incas did some of this. But basically, if it's very steep, and also if there's a lot of water, a lot of rain, Basically just build terraces, build levels, kind of stair steps. So it gives you land that's workable on an otherwise unworkable slope. And also slows down the water. So any sort of runoff from rain then has to go over those terraces versus just straight down the slope. So hope that helps. And yeah, have a good night.